goals of this DIGGS project, or this DIGG extension project, is to make it more Excel compatible, i.e. can we get something from Excel and get it into DIGGS? As one of the big problems we had with the previous version of DIGGS is that this was actually very difficult. Now to do that, what has happened is that Image Matters has created us a DIGGS web service. And the DIGGS web service is very powerful and very flexible in the way it works. So effectively what you do is you pass it a mapping file, which we'll have a look at that, and we'll pass it some CSV files, and we'll have a look at those, and it does some clever stuff that I've no idea how it does it, and it churns out a DIGGS XML file. So what we've done really for Keynetix for this project is that we've written an add-in for Microsoft Excel that creates these CSV files in the correct format, that allows you to add or manipulate this mapping file, and then after it's created the files, it makes the web service call to the DIGGS web service, and it waits for it to finish, and then it allows you to view the DIGGS file. So effectively we've done the clever bit up here, and Image Matters have done the clever bit down here, and we've linked the two together using their web service call, and then we can get the result using their web service call. So it sounds quite simple, but what we've had to do to actually make this to work is we've had to come up with a CSV file format for the DIGG structure, and we've had to come up with a mapping format for it as well. Then working with Image Matters on this mapping side, we've managed to effectively pretty much map anything you can in any DIGGS file, and I will demonstrate that to show how it works. So if we go into Excel, and we'll have a look at something quite simple to start with. So we've got a number of example files, and we can start with example number 1. And here we've got a very simple high-level piece of DIGGS information on the project name, their code, when the project started, and everything else. So all we do is we ask, we've got some document info in here as well, when was it created, software version, etc. And then we just ask the DIGGS tool to create DIGGS data from all sheets. So this now goes through, it creates the CSV files, it's created the CSV files, it's posted them to the internet, allowed the web service to do whatever it likes, and then returns it to us. And this is the file that it returns to us. So within this file, what you can see is that we've got the information that we put in here. So DLR 23099 is the project, Quinley Gasworks is the name, company details and everything else going through. Date start, date end. And one of the issues that people had were these GUIDs. The system at the Image Matters end now automatically creates these GUIDs, so you don't need to put in lots of information you don't need to. So we've come up with a system that allows you to put in information as you would expect to see it. So we can, let's just minimize that. So we can put in other things we want to. We can just put in some general information, or we can change the ID, and now when we create the DIGGS file from that information, we'll allow it to come up, and you'll see that we've changed the project ID and we've changed the location of this file to be USA. So what we've got here is a way that we can take this data. Now if we just look at the mapping file that comes with it, it gets a bit technical, but bear with me. We'll go up to the top and we'll look that we have an object called document information. We have allowable fields for that document, so this is almost like a CSV file called document information, and in that CSV we are allowed these column headings. We've put some description in the data dictionary so that people can see what they're doing, but with the new format of the data dictionary that the DIGGS team have done with Dan and Paul, this is probably not needed. Then this is the clever bit that Image Matters have done. Effectively what you do is you pass it that when it finds that column in that file, this is the XML path, the X path that it's going to. And there are lots of ways, and here you can see the auto ID field that says just generate the auto ID for this value, and if you've got any defaults you can put those in as well, so you don't have to keep typing your file format is in English. You can just set up your mapping to say this is always going to be English unless I've specified otherwise. And you can do this, and you can put this into all sorts of tables. So what we've been looking at just now in example number 1 is the document information, that was the first tab, and then the project. So the project, as you can see, what we've done is we've taken various aspects of the project group that would commonly be used, and we've flattened them. So here we've said, actually, within the project group you've got an associated files, and then an associated file, and then a file name. Well, we can flatten that down so that in the CSV file it's just called project associated file /gml : name. So it's a bit of a mouthful, but if that's your column name in the CSV file, it will magically appear in the right place in the XML structure. So here, if we go back to the file we were looking at a minute ago, we can see that that nests all the way into, we've got projects, project ID, remarks, content. You can see that that now nests in, and we can see that project, remarks, remark, content comes through from the remarks / content field in that file. So if we look at the example that we've got within the example file here now, this is the file we were looking at, and what the program did is it worked out what CSV files to create, and it created a very simple project CSV, and we can open that in Notepad and you can see what we've got. So we've got the headers here for the project group that you will see in the list behind. So all these headers that are in this group here are on here, and all the add-ins done is it's put the right data against each of the headers. Then what it does is it does that for all of the ones it wants. It zips the files together. So if we just look at this zip file, you'll see there is those 2 files in it, and then that zip file is what it sends to the web service for Image Matters. Image Matters then returns to us, and we save the XML file of the same name of the spreadsheet that you had in the first place. Now we can extend this out to be anything we like. So we can open up another example. If we go back and we actually look at sort of an example number 3, and we can look at borehole and trial pits. So here we've got document information, project information, and now we've got some boring locations. So here we've got 2 boreholes coming through with all of the associated information on them. So again, if we create from all sheets, it will create all those CSV files, zip them together, send them to the DIGGS web service, and then we'll get them back as our XML file. There we go. So now we've got a project, and we've got 2 sampling features, a borehole 1 and a borehole 2. So now you can see we can start to use our spreadsheets to build these DIGGS files quite quickly. Now the beauty of this system, in the way that Image Matters have put it together, is it means that developers who are looking to write export routines from their applications can effectively create CSV files pretty much in whatever format they like, and then they can either use the standard whole base mapping file or DIGGS mapping file, or they can use their own. So they can actually define their own mapping file if they want to as well. So within this you can then start to build up your own spreadsheets to look however you want. So I think the last example I've got here is if we just open it up and we go to example number 5, which contains a whole load of sampling information as well. So here we've got a document that starts to build project information, document information, borehole and boring locations. Then we've got some trial pits, some backfill information. Now this is really cool because it shows that this one sheet on the spreadsheet can include backfill information for 2 different types of objects as far as DIGGS is concerned. So here we've got a trial pit, which is actually a pit location, and 2 boreholes, which are boring locations. And then in this last sheet, which has got everything exposed so you can see what's going on, we've got a single sample. Now if we go and create that, takes a bit longer, it creates all the CSV data, sends the mapping service, wait for the mapping service to disappear, open a file, and now what we've got is the project information, some sampling information. Here's borehole 1, and we can go down and we can minimize some of this stuff so we can get to some of the backfill. Here's the backfill information there for borehole 1, and you see it's nested it all in the right place. It's done it all magically itself, all being done through the mapping file and the way the mapping file works. And then here we've got our sample that we put in as well, and our sample will refer back to the project that it's referring to and any locations it's taken from as well. So that's a kind of a whirlwind tour of exactly what the feedback tool does and how it works, but it really has made the creation of DIGGS data from either an Excel application using the DIGGS feedback tool, or from your own application just by writing the CSV files and doing a web service mapping call so much easier than it was in the previous version of DIGGS. And that kind of ends my presentation and demonstration, exactly kind of what we've done and how it works. And hopefully that's it.
Thank you, Roger. Yeah, good. Stop that. So we'll stop.